Hello everybody, how are you? You're doing very well. Today inshallah we start with section number 3, chapter 19, oxidizing and reducing agents. So let us first of all understand what do we mean by the oxidizing and reducing agent and what they do. So guys, to understand what do we mean by oxidizing and reducing agents, let us assume that we are doing the following activity. Okay, so label a small object such as an empty box with the word electrons. Ask another student to take the electrons from you. So let us assume that Bilal is holding this box, and then we asked Hussam to take a number of electrons from Bilal. Okay, so now the other student, which is in this case Hussam, was the agent of you losing the electrons, and you, Bilal, were the agent of the other students gaining the electrons. And you may remember, guys, that we said that oxidation is when certain atom lose a number of electrons, while reduction is when certain atom gain a number of electrons. So guys, by causing you to lose your electrons, this means that Bilal here, who lost the electrons, become oxidized. So who caused you to become oxidized? Bilal? Hussam, right? And that's why Hussam will be what we're considered to be the oxidizing agent, okay, because he caused you to become oxidized, while Bilal will be the reducing agent. Why? Because he caused Hussam to gain the electrons. Okay, so the student is reduced by you and you are oxidized by the other students. So here again, Hussam took the electrons from Bilal and he caused Bilal to lose the electrons, and he caused him to become oxidized. That's why Hussam will be the oxidizing agent. What do we mean by agent? Agent is something that will make something happen. Okay, so Hussam made Bilal become oxidized. That's why Hussam is the oxidizing agent, while Bilal caused Hussam to gain the electrons. Bilal caused Hussam to become reduced. That's why Bilal is what? Bilal is the reducing agent. Okay, so inshallah today, by the end of this lesson, we will be able to relate chemical activity to oxidizing and reducing strength, and explain the concept of something called disproportionation. Okay, so guys, what do we mean by a reducing agent? Again, a reducing agent is a substance that has the potential to cause another substance to be reduced, while an oxidizing agent is a substance that has the potential to cause another substance to be oxidized. So as we said in our example, the reducing agent which caused another substance to be reduced, it means that the substance will what? The substance will gain electrons, and the reducing agent in our example was Bilal, while the oxidizing agent was Hussam, because he caused Bilal to become oxidized, to lose his electrons. So guys, different substances can be compared and rated by their relative potential as reducing and oxidizing agents. For example, the order of the elements in the activity series that we have studied before in the first semester is related to each element's tendency to lose electrons. So actually, guys, elements in this series lose electrons to the positively charged ions of any element below them in the series. Okay, so the more active an element is, the greater its tendency to lose electrons, and the better a reducing agent it is. The greater the distance is between two elements in the list, the more likely it is that a redox reaction will take place between them. So guys, these elements and some other familiar substances are arranged here in this figure according to their activity as oxidizing and reducing agents. So guys, before we discuss about this figure, let us move back and explain this slide. Guys, different substances can be compared and rated by their relative potential as reducing and oxidizing agents, as we said. And here's guys, we have an important point. The negative ion of a strong oxidizing agent is a weak reducing agent, while the positive ion of a strong reducing agent is a weak oxidizing agent. To understand these 2 points, let us, guys, consider the following example. So guys, here we have this compound is the fluorine, and as we know, fluorine atom is the most highly electronegative atom, and at the same time is also the most active oxidizing agent. Okay, so because of a strong attraction for its own electrons, the fluoride ion, I mean the F minus, is the weakest reducing agent, as we can see here. Okay, so again, the fluorine as a molecule, the fluorine atom, as you said, is the most highly electronegative atom, and it is also the strongest oxidizing agent in our series here. And because of its strong attraction for its own electrons, the fluoride ion right here is the weakest reducing agent. So the negative ion of a strong oxidizing agent is what? Is a weak reducing agent. The second point says that the positive ion of a strong reducing agent is a weak oxidizing agent. And here we may talk about what? About lithium. So guys, here as we can see, lithium is the strongest reducing agent, but the positive ion of a strong reducing agent is a weak oxidizing agent, as shown in this figure. So lithium atoms are strong reducing agents because lithium is very active metal, as we know. But when lithium atoms oxidize, they produce the positively charged cation or positively charged lithium ion, which are unlikely to reacquire electrons. So lithium, or the cation here, are weak oxidizing agent. So guys, as you can see here in this figure, we have 2 columns. The column on the right represents the oxidizing agents, and the column on the left represent the reducing agents. As we can see here, as we move, guys, for the oxidizing agents, as we move down, the strength of the oxidizing agents will increase, while for the reducing agents, as we move up, the strength of these reducing agents will increase. So guys, according to this table, we can know which atom or which anion is better as oxidizing agent or as reducing agent, and according to that we can know which atom or which ion will displace the other in the chemical equation. So guys, for example, according to this table, we can see that the chlorine displays bromide ion and iodide ions, and bromine displaces what? It displaces the iodide ions. So the equation for the displacement of bromide ion by chlorine is as follow. Okay guys, we can see here we have the net equation and we have the half equations, the oxidation reaction and the reduction reaction, and we can see that the bromide ion, or the oxidation number of bromide ion, changed from -1 to 0. So this ion experienced what an increase in its oxidation number. So this reaction will be oxidation, and as we said, in oxidation reaction, the atom or an ion will lose a number of electrons. In this case, the bromide ion lost 2 electrons. These 2 electrons will be gained and accepted by by the chlorine. So chlorine here has been reduced. Okay, so chlorine here, the oxidation number for chlorine was 0. Okay, but after that it accepts 2 electrons, and the oxidation number of chlorine become -1. So guys, here we can see that in every redox reaction there is one reducing agent and one oxidating agent. In this example, the bromide ion is the reducing agent, while the chlorine is the oxidating agent. So guys, here we have 2 questions from the formative assessment at the end of this lesson. Question number 3, question number 4, please try to answer them. Question number 3 says, would chlorine be reduced by the iodide ion? And explain. We should refer to this figure, guys, in order to answer this question. For question number 4, in each pair, which is the stronger oxidizing agent? Okay, so guys, please answer them. There will be homework for you. So guys, finally we need to discuss about a term called disproportionation. So what we mean, guys, by disproportionation? It's a process in which a substance acts as both an oxidating agent and a reducing agent. Okay, so guys, a substance that undergoes disproportionation is both self-oxidating and self-reducing. The most important example for substance that will undergo this proportionation, guys, is the hydrogen peroxide. As we know, hydrogen peroxide has the chemical formula H2O2. So hydrogen peroxide is both oxidized and reduced, as we can see here, guys, in this equation. So guys, hydrogen peroxide H2O2 is a covalent compound, and it decomposes into, as we can see here, into water and molecular oxygen. Okay, as it's shown in this equation. So guys, here we can see that the oxygen atom that become part of gaseous oxygen molecule are oxidized. The oxidation number went from -1 to 0. Okay, so guys, the oxidation number of these oxygen atoms increases, as we said, from -1 to 0, while oxygen atom that become part of this water molecule are reduced, because as we can see here, the oxidation number went from -1 to -2, so the oxidation number decreased actually. Okay, so guys, this is what we call, or this is what we mean by this proportionation. As we said, it's a process in which a substance acts as both an oxidizing agent and a reducing agent, and the most popular example for this substance is the hydrogen peroxide. As we said, one of the oxygen atom will be reduced, the other will be oxidized. Okay, so guys, that's all for today. Thank you, and see you inshallah tomorrow.